Okay, so in the previous page, we mentioned P average equals I square, I RMS square R, okay? So according to the DC version, okay, for the DC version, we have P equals I square R, we have V times I, and also we have V square over R. We have three different versions. Yeah, but for the AC version, okay, for the AC version, okay, we already know that P equals IRMS square R is okay, and then I can also tell you that R square, VRMS square over R is also okay. These two are okay, but IRMS times VRMS is not okay. So here, P average should be these two, but multiply with this cosine of phi. Okay, this one we call the power factor. Okay, so this one you need to pay attention. Don't consider that for DC 1, 2, 3 versions are all okay, but for AC, okay, this is for the AC, okay, only this one and this one are okay. This one is not okay. The idea here is like, here we have a VT will be like, I should say EM and then cosine of omega T, something like this. And then IT will be EM, or maybe I can write it as an absolute value of I, and then sine of omega T, and then minus phi, like this. Okay. Here the point is that they are not in phase. 它们不是同向的。So when we try to calculate the P average, will be like a 1 over T integration from 0 to T, and then V times I will be like EM and then times I. Okay, and then we have a cosine omega T times sine omega T minus phi. Okay, dt. Okay, so if we would like to compute this one, okay, these two multiplied together, it will become something like, or maybe we can just, I mean, it should be like this one. For this one, it will become sine of omega T, and then cosine of phi. Let me see. Sine, cosine. Sine omega T. Maybe I also put this one to be sine. Okay, this one should also be sine. Okay, both of them are sine. Okay, Okay, so in that case, we will have this one, sine omega T minus phi will be sine omega T cosine phi, and then minus cosine of omega T sine of phi. Okay, sine of phi. Okay, so if you multiply this one with this one, we have sine square. Okay, so integrating it for a period will be 1/2, and then multiply by this one. Okay, so this one turns out to be this cosine of phi here. But if we have a sine of omega T times cosine of phi, okay, it becomes a half of sine 2 of omega t. Okay, integrating from here it will become a 0. So this term will be vanished. This one will be vanished. So in that case, as much as V and I are not in phase, this one I and V and I are not in phase, so we only have this, we will have this power factor cosine of phi here, So if you would like to use I RMS times V RMS, then we need this factor. And another condition to consider it is like we have V, the phasor divided by the phasor of V divided by the phasor of I will be Z. Okay. Yeah. So in that case, if we have so this is like R plus JX, okay, JX. Okay, in circuit theory, we will define this imaginary part to be X 就是这个是电阻嘛，这个是电阻，这个叫电抗。And then for this Z, in Chinese it's called 阻抗，阻抗。Okay, so this is X. Okay, this is X. So if we would like to consider the power consumption, it only related to the real part. Yeah, for this imaginary part, it is like just storing the energy there and then just oscillating inside. So in power system, we will call this is the active power, this is called the passive power. Some passive power are just stored in the LC element. They are just stored there and then doing some oscillation without any dissipation. 它没有被消耗掉，它是一些虚功，所谓的 passive power 就是一些虚功，它没有被消耗掉。那这个的话只算实的部分，所以它就会有这个 cosine， 因为实部的话是 cosine 嘛，那虚部的话就会跟这个 sin phi 有关，所以从 phasor 的角度的看的话，就是实部是这个 impedance of z 乘以 cosine， 它就是实部，Okay, so here we have a sample problem. So it says a series RLC circuit driven with ERMS to be 120 volt at frequency FD contains a resistance R and inductance with impedance ZL J80 and then a capacitor with impedance ZC equals negative J 150 ohm. And then what are the power factor cosine phi and the phase constant phi of the circuit? Okay. So here Z is R plus J omega L plus minus 1 over omega C. Okay, so here R is 200 and then plus J80 minus 150. So this is nothing but 200 minus J70 ohm. Okay. So the power factor phi will be arctangent of a negative 70 over 200. So which is negative 19.3 degree. Okay, negative 19.3 degree. So this is the phi. And cosine of phi is the power factor will be cosine of negative 19.3 degree, which is 0.944. This is the power factor. Okay, and the phase is 19.3, negative 19.3, which means the current and the voltage, the current and the voltage have a 19.3 degree phase shift between them. Okay, so yeah, so this is for question A, and then for question B, it asks you what is the average power P average dissipate in the resistance? Okay, so P average is E RMS square over Z, okay, times cosine of phi. Okay, you can consider this one to be V RMS times I RMS, E RMS times I RMS. Okay, because yeah, E RMS times I RMS. Yeah, because ERMS will be the VRMS, and then IRMS will be ERMS divided by the Z, absolute value of Z. Okay, so we need to multiply the power factor here. So this is 120 square, and then over the absolute value of Z. Okay, this is 200. And then minus J70. So this is square root of 200 square plus negative 70 square, and then cosine of phi is 0.944 according to the previous question. Okay, so this is 64.1 watts. 64.1 watts. I square So if you like, you can also use another approach. It's like IRMS will be ERMS divided by Z, or divided by Z will be 120, and then divided by this 200 square plus negative 70 square. So this is 120 divided by 211.9. Okay, this is 0.5668. Okay, so this is IRMS. So in this case, P average can be written as IRMS square and then R. So which is 0.566 square, and then times R is 200. So square times 200. So this is also 64.1 watts. Okay, so this is another approach. Okay, so this one is like IRMS. ERMS divided by absolute value of Z will be IRMS, and then multiply, and then the ERMS will be VRMS. Okay, ERMS will be VRMS. Okay, so in that case we need to consider the power factor. But here, if we just use the IRMS and then use the R, then we don't need this. Okay, and then still we have another question, C. So it says, what new capacitance C new is needed to maximize P average if the other parameters of the circuit are not changed? 就是说现在我们可以 改变一下这个电容的值啊，改变一下电容的值，让这个PFH 最大 ，PFH 最大。Okay, so the idea is like originally Z is this one 200 minus this J70. Okay, if we would like to maximize the PFH, we need to make the imaginary part to be 0. Okay, so in that case, we need to make ZZ new to be negative of CL. Negative of CL to be negative J80 instead of negative J150. So in this case, the new Z will be 200 ohm, okay, plus J0. Okay. So in that case, this is 1 over J omega C nu. Okay, J omega C nu. So C nu will be okay, J putting here will be -1, and then minus this -1 will be a plus 1. Okay, so this is nothing but 80 omega. So and then take the reciprocal. I mean 1 over 80 omega. 1 over 80 omega. So which means we put this C to the left side, put this 80 to the right side. So this is 1 over 80, and then omega is 60 hertz, which is 2 pi times 60. Okay, so this is nothing but 33.2 microfarad. So this is the new capacitor, so such that it can make the series impedance to be a purely real value, or make the imaginary part to be 0. In this case, okay, it can make the imaginary part of the Z to be 0, or make C to be purely real value, 就是纯的实数. So in that case, PFH is maximized. Okay, like this. Okay, so far any questions? Okay, so this is the last part of chapter 31 about the transformers. So in the real world, we have 3 types of transformers. And actually back in 6 years ago when I first teach this course, I will say in the real world we have 2 types of transformer. Now we have 3 types. OK, 所以现在的话我们有3种 transformers。一种是这里要学的变压器，另外一种叫做变形金刚，一种叫做变形金刚的 transformer。那第3种的话就是最近流行的这种 AI 的这种比如说要做自然语言的，就是比如说 ChatGPT 的话 OK， 那你们知道这个缩写是什么 GPT 啦那 Chat 你们当然知道是聊天嘛 GPT 是什么 GPT 是 Generative Pre-trained Transformer 所以它是 Transformer。这个 transform 在这种的 transformer 我不知道中文叫什么因为在中文圈里面都很少人会把这个说成中文因为我想过如果你真的要把它翻成中文的话，它就会变成一个叫做翻译器的东西你就会觉得它很 low 跟你说 transformer 好像比较厉害这种感觉，但是你要说它是一个翻译器，它就你只能说它原来叫 transformer 不一定是一个很好的名字如果你硬要把它翻中文的话，那听起来就更 low， 那讲英文的话也许就还好一些，所以 所以在中文圈，你在找 AI 的科普文章的话，也很少会把它翻译成中文啊。但是这个至少是现在第3种的 transformer， 但是我们现在要学的是第一种啊，叫做变压器。变压器，那变压器的话，其实跟30章最后的那个叫做 mutual inductance 其实是一个东西啊 ，mutual inductance 是一个东西。不过这里的话就变成一个 circuit model 啊。So here it says a transformer assumed to be ideal， 就是一个理想的情况之下，理想的情况是什么？就是它所有的 B field 它都没有流失，然后它中间也没有电阻去消耗它的能量，它就是一个理想的一个变压器。Okay, so a transformer assumed to be ideal is an iron core on which wound primary coil of NP， 就是它有2个线圈嘛，第一圈的话是 NP 转啊。然后第2圈的话是 NS 转啊 ，NS 转。Okay, so if the primary coil is connected across an AC generator, the primary and secondary voltage are related by this one. Okay, it is actually proportional to NS, and yeah. So I mean the secondary RMS voltage. Okay, so actually if you use RMS voltage for both, you apply for both, okay, both for the primary and secondary. If you use amplitude, it is still correct, okay. It just you just make it to make it consistent. 就是你 VPVS 的话，你2边一起用振幅，它会正确；你2边一起用 RMS 也会正确。你一边用 RMS 一边用振幅的话，它就不会正确。那这个的话，你用 so actually for this one, if you use the Faraday's law to imagine, it is easy to understand this. Okay, so the idea is like if you have an AC source, applied to the primary coil, of course it will generate the B field. Okay, and then there will be a current. Coil IP, and then this is called IS. Okay, so as much as this is IP, and then this is solenoid, you can regard it as a solenoid. You can regard it as a solenoid. Then, according to Ampere's law, you will have a B field to be mu 0 IP, and then over to not using this one. Okay, it should be like a mu 0 IN, mu 0 IN. Okay, mu 0 IN. Okay, so this is the B field. Okay, inside the solenoid. Okay, the B field inside the solenoid. We assume it is uniform. Okay, and then of course this is N. Okay, so you need to multiply by the. You need to actually n will be n will be the NP divided by the length there, divided by the length there. But yeah, you at least you can get some idea that this B field is proportional to this NP. Okay, this one should be capital letter. Okay. So you should have the idea that this B field generated by this coil will be proportional to the NP. Okay, and all the B field will be guided by this magnetic to the secondary coil. So we assume low B field leakage to the air. So if there are some B field leakage, then some power will be lost. Okay, so we assume all the power are transferred to here. So according to the Faraday's law, so this is and actually this I is a sinusoidal. So taking the derivative, it will become sine become cosine, or cosine become negative sine. So it is still a sinusoidal here. Okay, so it keeps generating induced EMF, and then also induced current here. And then also, according to Faraday's law, so this induced EMF or induced current will be proportional to this NS. So the idea here is like VP Vp, and okay, so we have a Vs is of course proportional to this Vp, and also proportional to Ns and inversely proportional to Np. So we have a equation like this, or you can write it as Vs Vp to be Ns over Np. Okay, so we have a SS, okay, and then PEP like this. Okay, and then also, as I mentioned, we have a conservation of energy. We assume all the power are transferred from the primary coil to the secondary coil. So in that case, IV equals IPVP equals ISVS, ISVS. So in that case, we have an equation like this. Okay, so if you write it in another way, we have a IS over IP equals NP over NS. Okay, so for the voltage, it is proportional to the number of turn, but for the the number of turn ratio. Okay, but for the ratio of current, which will be inversely proportional to the number of turn. Okay, 所以转速多的话，它电流就会小啊；转速小的话，电流就会多。Okay, so here we have two identity or two formula here. So here we can try to compute something called the R equivalent. R equivalent 就是在这个 R equivalent 的意思是在这里，在第一圈看到的等效电阻，哦，因为这里的电路是说哦，我有一个电源，有一个线圈，然后这个会 couple 到耦合到第二圈。那第二圈的话，这些能量用来干什么？用来给这个负载去消耗。这个是一个所谓的负载，是一个 loading 是一个 load 就是比如说这个是一个电灯或者是一个什么电器，它有一个电阻去消耗，那我们把它画成一个电阻我就不管它是什么电器了。OK， 那这样的话 ，OK， so in that case。Of course, for the secondary term, we know the impedance is out. We know the impedance is out. But for the first term, okay, the resistance seen by the primary term is not out. Okay, so this is interesting stuff. Okay, we can actually have for the secondary term, Vs over Is will be out, but Vp over Ip is not out. Okay, it is actually this stuff. It is Vp over Ip is we define it to be R equivalent, which is the impedance seen at the primary coil. Okay, and then we can make use of these two. We can, let's see. We can EPIP, IS. Okay, we can divide this one by this one. Which means we have Vs over Vp and then times Ip over Is. Okay, so we put this one here and then this one upside down and then put this one here. So to have a Vs Ns over Np, and then this one upside down, we have a Ns over Np, like this. Okay, so now we already have Vs over Is to be out. So which means this stuff will be out. So we have this is out times Ip. Vp. Okay, so we move this one to the other side and then move this one to the other side. So we have Np over Ns quantity square times R. Okay, it will be like that. Okay, so this means that for the primary coil, the resistance seen there will be not only out, which is multiplied by this turn ratio, then the turn for the for the primary coil divided by the number of turn at the secondary coil, and then taking the square. Okay, we will call this the impedance transformation. 我们叫做阻抗的转换，或者是甚至叫做阻抗的匹配有些情况 ，impedance matching 或 impedance transformation， 就是它会转换它的电阻，在第二圈的时候，它的负载实际上是 out， 但是在第一圈的时候，它会被这个 turn ratio， 就是这个转速的比的平方乘大或者乘小，看你的 NP 大还是 NS 大啊，它会转换。那这个有什么用呢？这个的话就会跟后面这个 sample problem 有关，我们再看这个 sample problem 啊。Okay, so for this sample problem is that transformer on utility pro operate at VP to be 8.5 kilovolt on a primary side. Okay, sorry. For the primary side, we have VP, and then supplies electrical energy to a number of nearby houses. 就是这个是一个供电的过程，就是这个是8500伏，相对比较低的，因为如果是发电厂出来的话是几百 K， 是几十万伏的，几十万伏的，是会比那个皮卡丘再高一些那这个是8500的话，就是说它从电厂产生出来的时候，它是几十万伏，然后它会降压传输到一些地区，然后在小区里面，它就可能再有一些降压的一些设备降到，比如说澳门的话220伏，或者是其他地方110伏之类的，所以它就会有这个转压的过程啊。那the nearby house is VS，OK， 在这个 case 是120伏。Okay, both quantity become being RMS value. Assume an ideal step-down transformer， 它也是假设一个理想的变压器。A purely resistive load and a power factor of unity， 它就是简化了，就是它没有 LC， 它就是 power factor 等于1，它这个的意思是说 cosine of phi 等于1让你最简单因为不然的话你还要考虑那个阻抗匹配不然的话就有些变成一些 passive power 在那个输电线上面震荡，它就是不好嘛，因为你给了一些功耗，但是它功耗没有输到对面，它在电缆里面在震荡，跑来跑去给了你就弹回来，弹来弹去就不好。OK， 那这里就假设说它 power factor 是1，完全没有 LC 震荡的问题。Okay, so it asks you what is the turn ratio NP over NS in the transformer. Okay, so for the first one, NP over NS is nothing but VP over VS. We just got this equation in the previous page. So this is 8.5 times 10 to the third power over 120, so which is 70.8. So this is just a ratio, so no unit here. Okay, 所以这个转速比的话是 70.8. Okay, so for the second question is the average rate of energy consumption in the houses served by the transformer is 78 kilowatt. What are the RMS current in the primary and secondary transformer? Okay, 他就问这个电流RMS current for the primary and secondary， 就是 IP 跟 IS 是多少？Okay, so IS will be P average divided by VS. Okay, so VSIS will be P average. So for this case, because we have a power factor of 1, otherwise we need to also consider the power factor here. Yeah, the power factor here is 1. Okay, so this is nothing but let me see. This is 120, and then P average What is P average? P average is here, 78 times 10 to the third power. So this is nothing but 9.28. Okay, so this is the RMS current for the secondary coil. Okay, and then IP will be P average divided by VP, so which is 120 over 78 times 10 to the third power over 8.5 times 10 to the third power. So this is this is 650. This is 650. This is 9.28. Okay, made a mistake there. Okay, so it should be like that. It should be like that. Yeah, for this one, lower voltage, higher current. Okay, higher voltage, lower current. Okay, so this is just some algebraic calculation. So okay, so for the part C, it asks you what is the resistive flow in the secondary circuit and what is the corresponding resistive flow RP in the primary circuit. So RS will be Vs over Is, which is 120 over 650, which is 0.18 ohm. Okay, 0.18 ohm. And RP will be Vp over Ip, which is 8.5 times 10 to the third power over 9.2, which is 922 ohm. Okay, so far we have already finished this sample problem. So here we can also explain why we need the high voltage for transferring the power. Okay, so the idea is like if we have a source, okay, if we have a source, and then according to the question, okay, it is like this. Okay, so this may be the from the factory, power factory, and then all the way up to the near your house, we have the step down transformer like this. Okay, and then finally the RS is the device at your home， 就是你家里的电器，它有一个 RS 的电阻。Okay, okay. So in that case, so this is a 0.18 ohm, 0.18 ohm to consume 78 kilowatt power. Okay, so this current, so in that case, this current here is 658. This current, and then the voltage, the Vs here is 120 volt. 120 volt. So in that case, for the primary coil, the current here is 9.2 9.28. Okay, 9.28. And then for the VP here is 8.5 kilovolt. 所以我们需要高压传输电的时候是说，因为这个电厂跟你的家的附近距离很远，所以它那个导线它肯定有电阻，它肯定有个电阻，有一个小的 R， 但是这个小的 R， 你学过26章的时候 ，R 这个是 R 会等于 ρ L 除以 A 嘛，那 A 就是看它多粗嘛。A 就是多粗 ，L 的话就是距离，这个距离可以很长，可以是公里以上的距离，所以它可能导电性能很好，但是距离你很远的时候，这个电阻还是可以很大的。那你要让它变小的话，那除了物质之外，你只能够把它用得更粗。 那但是有这个 out 的话，这个电流如果相对比较小的话，那它的损失就会比较小了，因为就比如说这里电流，我如果用了这个高压传输的时候，这个电流会比较小的，这个电流会比较小的。那因为这个9.2A 乘以这个 R， 这是它的损耗。那如果我直接就是用120伏的 RMS 去传输这个电的话，直接就给你，我不去降压，我直接先降好，用一个低压去传输的话，这样的话，你这里的那个电流你这里的电流是650A，然后这个电阻 R 其实是差不多的，从电厂到你家附近，跟附近到你家里，这一段可以忽略不计了。那这个 R 乘以650A， 那它的损耗就会大了很多倍就大了那个什么70.8倍大了70.8，因为它转速是70.8嘛，所以这个跟这个的比例是70.8，那你的 power 的 loss 就是大了70倍。所以就是我们就是需要的话，就是我们用高压传输，让这里的这个 impedance 很高，这里就是 high resistance high impedance 它就是 resistance， 这里的 resistance 是0.18欧姆，这里的 resistance 就会变成962欧姆。那大的电阻就代表说它的 V 大 I 小，那 I 小的话就是你 out 躲不了嘛，就是那些内电阻跟距离有关，躲不了。那我就尽量让在这里的电流降低，这样电流降低的话，那你的功耗的损失就会变小那如果你不降压的话，那你就要用一个比较大的电流，这个电流就是650A 去传输。那你650A 乘以这个小电阻的话，那你的损失就会大了很多倍。OK。